In this video, I'm going to show you how to calculate summary statistics for a set of data, including the population standard deviation, and also how to create graphical displays of histograms and box plots. So the data that I'm going to be using is actually from the standard deviation lesson. And what I want to do is use the data that is in this table. So I'm going to use these 10 data values. So in order to type that into the calculator, I need to press Stat, and it's going to bring up three menus: Edit, Calculate, and Test. And I actually want to edit a list. So I'm going to press Enter to call up the edit. Now, I actually have data already. It's not the correct data in L1. So I'm going to show you how to clear data that's already there. What you would want to do is arrow up to the name L1 and then press the clear button and then enter. And it's going to take out all the data so you're ready to type in. So what I'm going to do now is type in the 10 data values from the table for our example. And I'm just going to press enter after each one. So we have 22, 23, and so on and so forth. So if you'll type in your data, you'll be able to do some work on it. And one thing I want to note is that it tells you how many data values are there. So if you'll notice the last entry of 20, it says L1 of 10, which means it's the 10th data value. So I have the data entered, and now I need to calculate the summary statistics. So I'm going to exit out of this screen by using the quit button right here, and I'll go to second quit, and it's going to go to what I call the home screen. So from here, we need to go back to the stats menu, but this time we're going to arrow to the calculate. So arrow once to the right, and then we have one variable that we're working with. So we need the one var stat. So I'm going to press enter for number one, and it's going to tell me a few more items here, which is where's the data. So the list that we used was in L1. So it's actually defaulted nicely, but let's say our data was in L3. I might need to press second function and then the number 3 to get this L3. Okay, however, my data is in L1, so I'm going to go back, arrow to the left to highlight L3, and then I'm going to tell it second number 1 for L1. So each of the numbers 1 through 6 correspond to lists 1 through 6, and you can see the second function matches in blue with those titles. A frequency list would mean that I had a second list set up so that each data value in L1 might be represented more than once. So if you had a data value, like for Sarah, number 22, and you had 10 other students that had a 22, you might set up a second list. But in this case, we just want each data value to be used one time, so I don't need to enter anything for their frequency. I do want to calculate the summary stats, so I'm going to press enter, and it's going to give us a bunch of numbers. So what you'll notice from the lesson that we just did is that our mu, or the mean, was 21.7. So on the calculator right here, line 1, X bar, really is the sample mean, but we're using the population parameter mu. So 21.7 is what we had calculated. If I look down here, the sigma is the population standard deviation. And on the lesson, we talked about on 1B, the formula actually takes the sum of the square deviations, it divides by n, and then square root. So this number matches what we calculated. We wrote 1.418 centimeters, and so if you round the sigma here, you would get the same number. Now the sample standard deviation, S, is right above it, and so the difference between those two is that this calculation would actually be the same, except in your denominator, right here, well, not right there, you would be dividing by n minus 1 instead of n. So that's the only difference between those two formulas of S and sigma. Now, if you look, there's an arrow, which means there's more data below. Here is our n equals 10 data values again. And we also want to look at what we call the 5-number summary. So the 5-number summary in this case has a minimum of 19, Q1 or the first quartile of 21, a median of 22, a third quartile or Q3 of 23, and a max of 24. These 5 numbers are actually the values that are used to create a box plot, which I'll show you in a moment. Now, to create the histogram or the box plot, I'm going to exit out of this screen, and I actually want to go to the y equals button. So a couple of things that are important here is that I need all of these Y functions to be blank. Otherwise, it will try to graph the statistical data that's in the list and also some other function that's typed in. The other thing that I want you to notice is that the plot one actually needs to be highlighted, and only plot one if you're just doing one set of data. Now, sometimes we might want plot one and plot two if we're doing parallel box plots. But in this case, I'm first going to show you how to set up a histogram. So we actually need to go into this plot one, and to access that, we need this stat plot button. So we're going to press second y equals, and it's going to go into the stat plots. Number one for me is already turned on, which is why it was highlighted. So I'm going to press enter to go into stat plot one. And if yours is turned off, make sure it's turned on. And then we have several graphs. So the first graph is actually a scatter plot that's not connected, just the dots. The second graph is a connected scatter plot, and those two would be for linear regression. But what we want next is the histogram. So the histogram here is what we want to select. So I'm just going to press enter, and it's going to, again, tell us where is the data. So our X list is our L1. And remember, we had each data value represented once. We did not have a frequency list. So the frequency needs to be the number 1. Otherwise, it could be the name of a list. Now, once we have the parameters set here for the type of graph, to show the graph, we do not want to press graph from this screen. We actually want to press zoom, and you'll notice that there's a zoom stat. So this is going to be for the statistical displays. And I want to go down to number 9 and press zoom stat. Now, here is our histogram, and we can actually tell how tall each of the bins are and the width. So if I press the trace button, it's going to have the cursor highlight here, and it tells me that there are 2 data values that start at the integer 19, and they go up to, but do not include 20.25. So if we look at our data, what that actually is including are the integers 19 and 20. So we can go down to the list and see that Caroline is represented here and Heather. Now, back to the trace, I can arrow to the right and see there are also 2 data values in bin 2, 3 in bin 3, and 2 and 1 in the last 2 bins. If you wanted to change that, maybe to be integer values or integer bin widths, you could actually press the window button, and it looks like we are starting at 19 and we're going up to this number 25.25. So even though we had integer values, the calculator is just using an algorithm to create that. So I'm actually going to change that to be a number a little bit to the right. I'll change the min to be maybe a couple of data values that are smaller than our minimum. For my scale, I'm actually going to change that to the integer 2. So it's going to group every 2 scores together or 2 values together on the display. That also means that for the Y maximum, if you have several values in the height of the bin, you might need to change that to a bigger number. So I'm just going to go to 8, not exactly sure, and that's going to scale by 1. So from here, I would need to press the graph button after I've changed the window. And so it looks like everything was rolled up into 3 bins. So I can press the trace again to see how many data values are in each bin. So for the first one, I have basically 17 and 18, and there are no data values there. It doesn't include the 19. So that was where my minimum was. The next bin has 2 data values, which are basically 19 and 20. I have 5 data values that are 21 or 22, because it does not include 23. And then I have 3 more data values that are 23 and 24. So if you look at all of the ends, that actually adds up to 10, which is all 10 data values. So you can, play around with that to see what window you actually want or how many different bins you actually need. Now, if we wanted to create a box plot, I would need to go back to my stat plot menu and go ahead and select enter for number 1. And I would actually just choose a different type of graph. So I'm leaving this on, and my X list is still L1, frequency 1. That's all going to stay the same. But what you want to choose is the 4th graph, which is the modified box plot. You'll notice that the 4th and 5th graph look really similar. They are both box plots, but the reason why I want to choose number 4 is because it has these little dots to the right, which means it's modified. And if my data set had outliers, I would be able to see those using one of these special characters that's selected. So always want to choose the fourth graph. Now the next graph is the unmodified box plot. We usually do not want that one because we want to see if there are outliers or unusual features in the graph. And the final type of graph here is called a normal probability plot, and that's used in statistics to see if the distribution is normal. So with our box plot highlighted here, I still need to press zoom 9 to actually get the graph. And you can just press the number 9, and there's our box plot. Now, if you remember the 5-number summary, if I press trace, I can actually arrow to the leftmost point, which is the minimum of 19. And then I notice it says Q1 is 21, median is 22, Q3 is 23, and the max is 24. And those were the numbers from the 5-number summary that we saw earlier. So hopefully these tools will help you in your classroom of calculating the summary statistics and creating graphical displays for quantitative data.